Right. So in this devlog, we're going to create another executable. So last time we had the train program that will produce a weight file based on our configuration. So this will be our configuration for the train. We train the character of the alphabet of the Magi using this topology 1125, 200, 1125, having 200 neurons in the hidden layer, learning rate 0.05, momentum 1, bias 1, and we've trained it for 100 epoch rounds. So it would read from a file as specified in our config. Label data will be the same file as well because we're trying to do an autoencoder in this case. That will attempt to reconstruct the input, learn how to basically learn how to reconstruct the input. That's why we have the same output here as 11025. And it will store the weights in this file, magi character 01.json, which is here. Oh, sorry. Weights, okay, which looks something like this. Okay, which stores all the weight files, or all the weight values rather, for the given training set. So what we'll do now is we'll create another executable that will simply take that weight file. Okay, we'll call this classify. Right, and it will try to guess another set of data that using the weight files that we trained for the character 01. So just to give an example, let's see. What where I put it? Omniglot. Right, so Omniglot dataset, we have here alphabet of the Magi. So this is what we try to learn, right? The set of characters. So the idea is what happens if you run the classification against this character, for example. Right? So using this configuration of 11025, 2111025, it should produce an error rate that's high, at least as the theory, because it's drastically different from this particular character. So the network learned how to reconstruct this one, but we're trying to see how the error rate when it tries to recognize this one as character 1 of alphabet of the Magi. Okay, so to do that, the first thing we'll try to do is to create a function that will load this weights file. Well, I have it in C. I have it as an executable here in CMake, so I'll use all the components that we did for our neural network, and our main class or our main function will be found in another file called classify.cpp. So just to make things faster, we're going to create that file classify.cpp and just copy and paste the contents from train.cpp. Okay, so we say that the syntax will be classify followed by the config file, okay, followed by the test file, right? Or it would be a set of CSV file, a CSV file containing the vectors that we'd like to try to classify using this configuration. Okay, so in this case, we'll still need the topology, the bias, the epoch, well, actually not the epoch, the momentum. I don't think we need this, because technically we'll just be performing a feed forward, right? No more learning rate because we're not going to train anything. No more training data. We need the weights file, as well as the no need for the labels file, but we do need the test file, right? Okay, so we say something like test file equals config test file. Topology will still be the same. Okay, right, we still create a neural network based, oh, okay, so apparently our constructor should accept a learning rate and momentum for a neural network. So in this case, just to avoid creating another constructor, let's just set this to 1. Okay, since we don't really need well, actually I think I have a default value for that. Let me just check. Right, I have this one. Or rather this one. Yeah, this one should do. Okay, use the same hidden activation, but I don't need to pass in the bias, the learning rate, and momentum. I'll just have them as the defaults. Okay, so it will be something like this. Right. Okay, so I won't need the training data, but rather we'll be reading a file from test data. Okay, we won't need this epoch part, just so we get a high level overview on how the program will flow. So right, okay, so we have this one. We're just setting it up, reading the config, reading the stuff, weights file, test file, topology, set up the neural network, set up the test data as well. Okay, fetch from test data, sort in a vector of doubles, and essentially what we want is we need something like n load weights, which will accept the weights file as the argument, right? So we need to set that up in our header file. Let's put it right beside save weights, so we have something like void load weights from the given file. Okay. I actually have the code for that from the previous iteration. Just check it out. Load weights. Right, so I think I can just copy this and right, I can just copy this from the old one. Let's see now. Alright, so inside here. Load weights. Okay, I'm gonna copy it to SRC neural network. Oops. Neural network. Okay, so it should be here. There we go. Load weights. Okay, so what this is doing is that it accepts a file name, which is the location of the JSON weights file. It reads that file, and using again JSON, the JSON C++ library, we declare it as a JSON data type, JWeights, and then pass the entire JSON to that variable. Right. So this one can be casted to a set of vector of doubles, right? Because we need the outer vector will present the different layers, the next layer of vector will present the rows, and the inner vector will present the columns of the matrix. So this is basically the middle vector, and the inner vector will represent the matrix of values for the weights for the in between consecutive layers. So we have it as a vector of doubles, which we take from the weights file. And what we're doing here is we're simply loading the values from this vector of doubles into the weight matrices variable of the neural network. Okay. Once we have that, And once we have the test data, we can essentially loop through the test data. Size I plus plus. Okay, and ideally we want to do something like classify, right? So think of the best way to perform classification in the case of this problem, because usually the classification will be the highest value of the neuron in the output layer. If you treated the output layer as a set of classes or labels, right? So say you have 4 in the output layer. Each of those 4 neurons will represent a label or a class in your data set, and whichever one has the highest value will be considered a classification of the input. So in our case, we're doing an autoencoder. So just to probably differentiate classify from a typical neural network and a classify for an autoencoder, the autoencoder will base its classification on the weights. Okay. Actually, let's just make the code work first. So we need an error value, okay, which we can actually get from error, right? So you have a single error value here, wherein we say well, actually, first things first, we'll have to perform a feed forward. Okay, feed forward from the neural network by setting up first the input. Okay, so remember we had forgot the function. Right, set current input, which accepts a vector of double values as the input. Okay, we don't, and well, we ideally we'd also want the target, right? But in the case of an autoencoder, the target will also be the input, because we'd like to attempt to reconstruct, because we're learning how to reconstruct a particular input, and then we get the error based on the reconstruction. So at least for this particular classify.cpp, we say something like n set input, set current input rather, okay, where the current input will be test data at that particular index, and we say set current, or rather set targets, set current target, right? Set current target will be the same thing, right? And then we try to get the error. So we say error equals n error. We try to display that. And something like error for data point I, and then you print out the error right there. Okay, so before I try to compile it, let's go ahead and create a I'll make this more specific, right? I'll name this autoencoder .json. Okay, let's just copy the contents from train. Okay, so it will be the same topology, momentum and everything. You can actually remove the momentum, epoch, and the learning rate. And what we need is the weights file. Okay, so we have it right there, and the test file. Test file. Okay. Now let's sorry, test file. Let's try to run it against itself. Meaning we train the autoencoder to learn how to reconstruct characters from the Magi character 1 dataset, and then we'll try to sort of reclassify it, see if it will have a low enough error for this one. using the weights found in using the same weights is in Magi character 01. Okay. Okay, just to make this probably more intuitive, we'll say that the classification will be named Autoencoder classify. Yeah. Autoencoder classify or classify autoencoder. I'm not sure which one's better sounding. Autoencoder classify. Yeah, okay, we can just leave this as this for now, and say autoencoder classify. Right. Okay, and of course, let's try to compile it first. Hopefully this works. Okay, we have an error at fetch data. Line 48. Oops, sorry. Fetch data, test data. Okay, it shouldn't be it shouldn't be test data, it should be test file. We're actually passing a string. Try to make that again. Come on, 100%. Undefined reference to load weights. Let's check out the error right there. Right. Doesn't know how to build load weights because we haven't included it in our classification or our compilation. So we say neural network load weights .cbb. Oh, okay, so we didn't have save weights as a separate file, so try that again. Alright, so now that it's working, I think we forgot to. Right, we need 3 arguments for this, right? Let's clear this up. Right, so if you run autoencoder classify, right, we need to pass the config file and the test file. So in this case, well, actually, we already have the test file located here. No, rather located here, right? Test file. Okay, so we don't really need the third argument because it's already embedded in the config file. Okay, so we can just say, so it's just exactly the same as the train program, just accepts 2 arguments. Right. Let's change this to right, so we need to pass a config file to it. So we'll go ahead and pass that config, okay, from config. So config autoencoder JSON. Okay, so it's going to initiate itself, load up the network, load the weights, fetch the data, loop through each data, and try to output the data. Oh no, wait, we're missing something. Set current target, set current input. No, this won't work. We need to also, of course, perform feed forward. Right? Feed forward. Yeah. Okay, feed forward. So we're only doing a feed forward, not changing the weights. So we're using a fixed version of the weights as loaded by our load weights function. Okay, so we load the weights, we set the input per data row in our test data, set the target, which is the same thing, perform a feed forward, and okay, I'm missing one more thing. Because we want to get the error, okay, we need to call set errors. Okay. Set errors will take a look at the target, try to compare how far the guess is from the actual input. Okay, and then display the error right here. We'll try this again. Okay, and remember, we're trying to classify the character 1 in alphabet of the Magi using the same weights, using the weights that we use to train it. So I'm actually expecting the error rate to be quite low in this case. I actually forgot to record the error for the error when it was training because I left it alone. So while that's happening, let's go ahead and let's go ahead and pull out our image to vector program. Okay, so this one will accept an input directory and an output file, which will vectorize a set of images similar to what we did with alphabet 1, right? So we're going to do the same for alphabet 2, character 2 in this case. Okay, and then we're going to save it in a vector here in data. Okay. So I'm going to run this. This one is found in Omniglot, Python, I believe, images background, alphabet of the Magi, character 02. Okay, so this is the directory, and then the next argument will be the file. So it will be stored in just to maintain consistency, Magi character 02.csv. Magi, I'm sorry, rather an data character 2.csv. Done. Alright. So we have another data set here which corresponds to character 2, and you can see that, okay, I forgot to put a new line, but you can see that it's producing the errors for feed forward setting up for trying the test data, which is the same data itself. So let's put a new line here. Okay, compile this again and rerun it. Okay. Now while waiting for that, so we have for character 2, let's go ahead and create another one for character 3 and character 4 of the alphabet of the Magi. For 11025, 211.025. Okay, so now we have 1, 2, 3, 4 data sets. Okay, let's just wait for the error for this. Now, while waiting, let's go ahead and store results in an Excel file. Maybe I'll just store this in Google Docs. Spreadsheets. It's taking a while. I can't remember how long it took to reinitialize this. Actually, for the next run, I'd like to do a comparison. So it would be something like just so we can copy paste it in Excel or in a spreadsheet. So we'll say something like data point I plus 1, comma, and then the error. Right. Okay, so we have that. Let's comment this out. Try to do it again. Okay, so we have it in this format, so we can copy paste the contents. I'll put it in our spreadsheet. Let's do this alphabet of the Magi test 1 autoencoder. Okay, so we have here character 1, data point, character 1, character 2, character 3, character 4. I forget how many did we have? We had 20, right? We had 20 data points. Let's try it again. Okay. Could do a bunch of other characters. Let's just have it until character 4. Okay, so we have our values coming in. They should technically be the same values. Yeah. Alright. Let's go ahead and copy this. I shouldn't have put the data point label there. Yeah. Okay. Just gonna do a simple find and replace. But anyway, I'm just gonna print out the error so it's easier to copy and paste it in the Excel sheet. So quickest way I can get rid of all these data points, because I can't do a simple find and replace for this. Try it out offline. Okay, there you go. Such a tedious task. Alright, so we don't need to rerun this again. Let's try it for the next next file. So we're going to use the weight file of character 1 and try to classify character 2. Hopefully we get some good results. I'm not quite optimistic about this. Alright, so this one is a low error. Relatively low error based on the training data, of course. We're going to do the same for character 2, 3, and 4. As you can see, for this topology, it technically did not it did not reconstruct it completely, because if it actually reconstructed the input completely, then this value should be close to 0, right? 0.1 or something. Maybe if we actually trained it further, then maybe it might fall down closer to 0, but In our case, it really didn't work out. It was just for 100 rounds. So we close this. Oops. Okay, let's just wait for that. Actually, I can run multiple instances of this. Alright, there we go. See? So the error rate is actually much higher than the one for the original dataset. Right. Okay, so we're gonna copy this. Place it there. Okay, we're gonna try one for character 3. That work. Okay, so it hanged in there a bit. We just restart everything. Sorry about that. Okay, sometimes Vim does that to me. Oops. Okay, so it's still stuck there. Okay, what's wrong? Let's go the old-fashioned way without Emacs. Alright, so change this to character 3 and rerun this one. Okay, so we have data for character. Now, of course, this one is technically cheating, right? Because you're using the same data that you used for training and then trying to classify itself. So naturally, it will have a lower error rate. So what we want to do is, well, as a human being, I know that this one, I recognize that there are some similarities between the files that we find right here. So what I'll do is I'll create my own, I'll draw my own thing. So maybe if you have a drawing tool here online, draw tool, yeah, sketchpad, I guess. Okay, we're gonna create our own character 01 and see if we can actually recognize it. Okay, so essentially what I want to do is I want to draw something, right? I'm gonna vectorize it. Let's say I draw 10 samples of these characters. How does this look like? So you have a thing there, a U-shaped thing. I'll just go try for one. There's a pointy thing here. And like a dot right after this. Okay, and then it has this tail with an edge that sort of points towards there. So tail here with an edge. So I think that's character 1. Okay, let's go ahead and try that out. Crop this. Okay, and we're gonna fix it for, how big is this picture? Hang on. Character 3 is done. right here. Okay, I'm gonna go ahead and try it for character 4. Using the same weights as Magi character 1. Okay, and while we're waiting for that, go ahead and try our it should be a square. 11025. Let's do some quick calculator here. 11025 square root of that, or rather square root of 11025, 105. So we're going to resize this to 105 by 105. Okay, so it should be that big. Okay, so try it again. Okay, this is quite annoying. I'm just gonna go and print screen this thing. It should be somewhere here. There we go. Put it in. Let's put it in pictures as well. So I'll say character 01. Okay. Okay, and then I'm gonna create another one. Kinda looks like it. Where's our reference? One. Let's try to draw something like this without the dot, but with the U shape, with the edgy thing there, and a tail right there. Try that. Oops, tap it. A U shape thing there with an edgy thing right there. No dot, but we have an edge there. So it's still technically character 01. Let's try to zoom out a bit. Close this first. I'm gonna print screen this. I'm gonna go ahead and draw another one. Let's just do 3 for now. Let's see if I remember the way it looks like. Let's put a dot there and a tail edge right there. Okay. Actually, let's try to make it a bit what do you call this? Try to make it a bit rotated, slightly rotated. Right. Let's screen this thing, and then we're going to resize it so it has some warping. And let's see if we can fairly classify it in a. If we can classify it in a rather. Nautilus is acting up again. Okay, so we have 3 characters here that kind of look similar, but actually not. Alright, so we have to resize this. Let me just open up the GIMP. Okay. Alright. before I do the resizing, let's copy this. That's for character 4. Okay. Quite different from character 2, 3, and 4. Okay, so let's try it out now for our case. So I have to resize this. How do I resize this? Scale. Oh, there you go. I'm going to scale it to 105 by 105. Scale. Okay, so it looks something like this. I'll export this. Okay, I'll name this one.png. Okay, we're okay for that. I'm gonna do the same thing for this one. 105 by 105 scale, and we're going to export this to and finally the third character, 105 on 105 scale, and export that as 3. Okay, so now that we have those 3 characters, we're going to do the same process as we did with our just delete the screenshot. Oh, what happened here? Oh no. Okay, we don't want this. This one is a different measurement, I think. Yeah, it's still... What did I do? Okay, let's repeat that again. Alright. Image. Scale image. 105. 105. Let's break this. Scale. Okay, why is it that way? Scale image 105. 105. Okay, so there's a bit of warping. Let's do it again. There we go. Got to turn the camera on. Okay. 105. Scale that. Export. That's weird. Okay, let's check the properties, make sure that it's okay. So 105 by 105. All right. Oops, sorry again. All right. So my characters are 1. Okay, under pictures, let's just delete these things. I'm gonna go ahead and run our image to vector tool. Pictures, character 01. Okay, so that's the folder, and the data will be my Magi character 01.csv. Okay. Right, so produce the vector file for my Magi character 01. There are some slight variations, I guess. You have 0, exactly 0. Yeah, we have a bunch of zeros. Okay, there's some slight variations, but variation is good, just so we can see how well the network recognizes the characters for values 0 to 1. Okay, so we change this config file for Autoencoder. Change this to my Magi character 01. Using the same weights produced from Magi character 01. And let's see if this one works. So Autoencoder classify config autoencoder.json. Hopefully this works. Okay, so the expected result will be somewhere close to this one, right? So it shouldn't be like 300 or 400 or 200. If this was a good model, then it should have recognized somewhere close to these error values for an epoch of 100, of course. And just for these 3 images. Kind of looks similar. Okay, so I think what it was able to do is the weights are I guess diverse enough or specific enough for character 1, because you can see that there's actually a large difference between these values. Right, if you sort, maybe if we graph them, can we graph them later on? Just say for this row. Right, so there's a big difference. So this one is the character 1. This is the second character, the third character. This. All the way to character 4, right? So it can distinguish itself from the other characters, right? Because it has a relatively high difference between the error rates for that particular type of Magi character. Okay, so this is bad. Yeah, this is bad. So maybe an overfitting of data, I guess. I wasn't expecting this. Let's try to see visually what this means, right? Let's go ahead and pull up the original Omniglot character 1. Right, so if we were to compare it, right, it sort of has a different scale, right? So the drawings here are sort of centered, whereas the drawings that I made were blown into proportion. It sort of almost touches the edges, so maybe that's why it can't classify it properly. Right, because this one is relatively smaller. So I guess what we can see here is that even if it can distinguish the other characters from itself, it's not necessarily scale variant, right? Right, meaning a change in the scale of the picture, even if it looks like the same thing, will not necessarily yield good results. It will try to think of it as another thing. Okay, so maybe that's one improvement we can do for the next log. But at least we get, I guess, the value here is that we get some sort of, we got to program some sort of utility to perform the classification part and test to see if those weights actually perform well for distinguishing other characters aside from itself. Right, so I guess we'll end with that, and we'll try to figure out ways to make this model scale invariant, right, despite having as few data as possible. Right, so that's it for this video.